Hello and welcome to your very first project on regression. We have selected a very basic project in order to get you started and to introduce you to the concept of linear regression. In this regression task, we are going to predict the number of marks that a student can score based on the number of hours that they have studied. As this is a simple linear regression task, it involves just two variables, namely the marks and the scores. And we want to map a relationship between these two variables using the linear regression algorithm so that we are in a state to make predictions. So let's get started. The first and the most important step is to import necessary libraries that will help us to get our work done. A Python library is a collection of pre-written code modules that offer a wide range of functions and tools to perform specific tasks. It is going to make our life easier because certain functions or classes that we are going to use has been already written and we don't need to write that from scratch. We can just import them from these libraries and get our work done. That is why it is very important. Okay, so in the first line you can see that we have imported the pandas library. The pandas library is used to manipulate data using data frames. Using this library we can perform analysis on our data. You must also be wondering about the role of the as keyword that we have written here. So this as keyword allows us to assign an alias or a shorter name to the imported library or module. In this case, we can see import pandas as PD means we can refer to the pandas library as PD. And throughout the notebook, wherever you are going to encounter this PD keyword, it is actually referencing to the pandas library. So it is just used for the purpose of convenience. So instead of writing out the whole pandas each time wherever you are importing some function or module from this library, instead of doing that, to make it convenient and easier, we can use just PD. The same thing is happening in the next line of code where we are importing the NumPy library. The same thing is happening in the next line of code where we are importing the NumPy library as NP. So throughout the notebook, wherever you are going to encounter the NP, it is actually referencing to the NumPy library. Now, NumPy is short form for numerical Python, and as the name suggests, it is used to perform mathematical operations on arrays. After that, from the linear model module of the sklearn library, that is the scikit-learn library, we have imported the linear regression class. This class helps us to perform linear regression. Now, how do we know that it is a class? Because of its naming convention. So the way it is named here, it represents the naming convention for a class. So we are able to distinguish that it is a class. In the next line, from the model selection module of scikit-learn library, we have imported the train test split function. Again, the naming convention suggests that it is a function. This particular function is used to divide the data into train and test set. Next, we have imported from the metrics module of this scikit-learn library the mean absolute error function. The name is self-explanatory. This function is used to calculate the mean absolute error, and we will be utilizing this to evaluate the performance of the linear regression model. Apart from this, for the purpose of visualization, we have imported two libraries, that is Seaborn and Matplotlib. Please note that Seaborn is made on top of Matplotlib. It's just that its visuals are a bit better and it provides a few functions where we can visualize linear regression. That is why we have imported it in this project. Okay, so also this particular line here, that is Matplotlib inline, allows you to quickly and easily visualize your data without having to save plots as image files or open them in a separate window. So now that we are familiar with the process of importing necessary libraries, we can move to the next step, that is loading the data. Data loading is the foundation of any data analysis task. It allows us to bring in data from external sources such as files or databases into our Python environment. Once the data is loaded, we can perform various operations on it, such as cleaning, transforming, and analyzing it to gain insights. So let's start with this step. When working with data in Python, one of the most important tools you will come across is the data frame. And here also what we are trying to do is, we are trying to load the data into a pandas data frame. A data frame is a tabular data structure that organizes data in rows and columns similar to a spreadsheet or a table. It's a powerful tool for data analysis and manipulation, and it's relatively easy to understand and work with, especially for beginners. Also, the format of the data is also very important. Here we are using a CSV file. A CSV is one of the most widely used and simplest data formats. It represents a tabular data in plain text where each row corresponds to a record and values within a row are separated by commas or other delimiters. CSV files can be easily opened and edited using spreadsheet softwares like Microsoft Excel or Google Sheets. Now, coming straight to the code, here we can see that we have defined a variable called data, which is storing the value of a URL. Okay, this URL is pointing to a CSV file stored on the web. The data in this file is the target for loading into the data frame. If you will visit this website, you will be able to see our data set in a CSV format containing two columns, one representing the marks and the other representing the scores. Now, in the next step, we can see that we are making use of the read CSV function from the pandas library. So, the read CSV function is used to read the data from the specified CSV file. As you can see, to this function we have passed the particular URL of our data set. It takes the data URL as the argument and retrieves the data from that location. The function parses the CSV file and returns a data frame object containing the loaded data. In the next line, rawData.head method is called to display the first 5 rows of the data frame. This provides a glimpse into the loaded data and helps to quickly assess its structure and contents. As you can see, there are two columns. One represents the hours the student have studied and the other represents the marks scored by the students in percentage form. One thing that you need to note here is that the head function displays the first 5 rows of the data frame, but you can specify a different number in the parentheses here to display the first 10 rows or the first 20 rows according to your liking. But as the default, it will only show 5 rows. So far in this section we have learnt how to load a data using a URL into a data frame. Now we can also check the general information of this data frame by making use of the info function. So as you can see, on this data frame called raw data, we have called the info function. The info function provides an overview of the structure and the metadata of the data frame. It displays useful information about the data frame, including the numbers of rows and columns. As you can see, it specifies that there are 25 entries, 0 to 25, and data columns are 2. Okay, so it means there are 25 rows and 2 columns. The data type of each column, the memory usage, and the presence of missing values is also shown through this information function. As you can see here, the first column is the hours column and there are 25 non-null values. It means that there are no missing values, all 25 values are present, and the data type of this column is float. For the other column, the scores column, also there are 25 non-null values. It represents that there are no missing values in the data frame, and the data type of this column is integer. After that, you can see again the data types, like here it mentions that there is one column with float data type and one column with integer data type, and the memory usage is 528 bytes. So now that we have learned how to load the data, we are ready for the next step, that is visualizing the data. Now we have come at a stage where we can visualize our data, which allows us to uncover meaningful patterns in it. By visualizing our data, we can better comprehend its underlying structure and derive valuable insights that may not be apparent through raw numbers alone. Let us see step by step how we can visualize our data using a scatter plot. We will analyze this set of code which we have used to visualize our data by making use of a scatter plot. To begin with, we set the plot style using the setStyle function offered in the Seaborn library. We have set the style to dark. This sets the overall appearance of the plot to a dark style using the Seaborn library. The style determines aspects such as the colors, grid lines, and fonts, giving our plot a specific visual theme. You can choose any style of your liking when you are working on the code. In the next line of the code, we are actually making use of the matplotlib library here. As you must remember that PLT is the alias or the shorter name for the matplotlib library that we have imported earlier in the project. By making use of the figure object from the matplotlib library, we are trying to set the size of the figure. Here you can see that to the fig size parameter, we have passed in the width and the height of the plot that we want to make. So the fig size parameter allows us to specify the width and height of the figure. In this case, we set it to 14 inches in width and 7 inches in height. This provides us with a large canvas to visualize our data and allows us for better clarity and detail. So by now we have set the style and we have set the figure size as well. We then plot the data points on the graph using the following line of code here. This line of code creates a scatter plot where each data point is represented as a marker on the graph. Again, you can see that we are making use of the matplotlib library. In that library, we have used the scatterplot function, to which we have passed the raw data as the x-axis values and the raw data scores as the y-axis values. In the next two lines, we have passed in the names for the x-axis and y-axis, namely. Again, we have made use of the matplotlib library here, and we are accessing its two functions called xlabel and ylabel, which helps us to name the x-axis and y-axis respectively. After that, we are making use of the show function to display the plot. This function renders the plot and shows it in a separate window or within the Jupyter Notebook IDE output area. Okay, so once you run this code, you will be able to see a figure like this. This is our scatter plot. You can see that the x-axis represents the hours, the number of hours that the students have studied, and the y-axis represents the number of scores the student has achieved. We can clearly see that there is a linear relationship between these two variables. We can see that as the number of hours studied increases, the number of scores achieved by the students also increases. So there is a positive linear relationship between these two variables, which we are easily able to identify by making use of the scatter plot. This we may not have been able to ascertain by the means of data frame above. As you can see, just from the data frame we were not able to make out any relationship between the hours and the scores variable, but when we plotted it using a scatter plot, we were able to identify a linear pattern between these two variables. That's why visualizing the data set is a very important part in data analysis. We have now learned to visualize our data and to identify trends from it. Now we are at a position to go to the next step, which is training a linear regression model. Before we come down to the actual model training part, we have to make a few preparations. This preparatory step is called feature engineering. So feature engineering is the process of transforming raw data into meaningful features that effectively represent the underlying patterns and relationships within a data set. It involves creating new features or modifying existing ones to enhance the predictive power of machine learning models. Now that we are familiar with the concept of feature engineering, we will proceed with feature engineering part of our project in a step-by-step manner. Please note that specific steps and techniques involved in feature engineering can vary from project to project. So it doesn't mean that the steps that we are going to follow in this project would apply in the same way to the next one, although the gist remains the same, but a few more steps may get added in another project as compared to this one. This is a very basic project, so there is very less or next to no feature engineering involved in here, but here we are introducing you to this step. So the first thing is feature and target separation. In feature engineering, it is essential to separate the features, that is the independent variables, from the target variables, that is the dependent variables in the data set. This separation is important for model training. Now, in our project, the independent variable is the number of hours studied by the students, and the dependent variable is the number of scores achieved by the students. In here, you can see that when we access the hours column from the raw data frame, it is coming out like this. This is a panda series. Okay, similar way we are doing with the scores column, and we can again see that this is a panda series which is being indexed here. This is the index from 0 to 24, specifying the 24 rows. Okay, now coming to the code. This set of code here demonstrates the separation of features and targets. In this code, the variable x represents the features, specifically the hours column here, and the variable y represents the target, that is the scores column. Okay, please note that the values attribute here is used to extract the values from the data frame, resulting in a two-dimensional NumPy array. The double brackets here, as you can see, we have accessed this column using a double bracket here. These are used to select the column as a data frame to maintain its structure. So we are accessing the hours column as a data frame to maintain its structure, and then we are converting it into a two-dimensional NumPy array. We are doing this in order to meet the requirement of the model that we are going to train. Okay. The linear regression model from sklearn library expects the input in the form of a two-dimensional array. That is why we are transforming our features and targets in the required format. So, the x represents the features and the y represents the target. So now we have to separate variables for features and targets respectively. So this is separating the features and target. Now you can look that how the hours have changed, that is x that represents the hours. Now the format is that of a two-dimensional array. Okay, and the same is with the scores, it is in form of a two-dimensional array. You can also check it by making use of the shape attribute here. You can see that there are 25 rows and one column for each of the feature and the target, because in feature we have only one feature, that is the hour, and similarly we have one dependent variable or the target, that is the scores. After separating the features and target variables, The next crucial step in the machine learning workflow is splitting the data into training and validation steps. This step is important for model development and evaluation. The purpose of splitting the data is to create separate sets that can be used for training the model and evaluating its performance. The training set is used to train the model on a subset of the data, while the validation set is used to assert the model's performance on unseen data and tune its hyperparameters. Okay, so that is why we need to divide our data into train and test set. For that, we are making use of the train test split function. Now, after separating the features and target variables, the next crucial step in the machine learning workflow is splitting the data into training and validation sets. This is a very important step, and the purpose of splitting the data is to create separate sets that can be used for the training and the model evaluation part. The training set is used to train the model on a subset of the data, while the validation set is used to assert the model's performance on unseen data and tune its hyperparameters. Here we have made use of the train test split function that we have imported from the scikit-learn library earlier in the project. The train test split function is a part of the scikit-learn library in Python and provides a convenient way to split the data into training and testing set. It randomly shuffles the data and divides it into two portions based on a specified test size or train size. By default, its test size is 0.2. That means that it divides the data into train and test set in the ratio of 80:20. Which means that 80% of the data would be used as the training set and 20% of the data would be used as the testing or validation set. This is the code here. Please note that first we specify the x variables, x train and x test, and then we specify the y variables, y train and y test. This is the correct format of using the train test split function in order to generate the two sets. One convenient way to remember this convention is by looking at the parameters of the train test split function. You can see that first we are passing in the features and then we are passing in the target. Similarly, here also we are following the same convention, that first we are assigning the x variables and then the y variables of each train and test set. Coming back to the train test function, we have seen that we are passing in the feature and the target, and the test size we are using the default value, that is 80:20 ratio. Here the random state we have set it as 0. Now the random state parameter is used to ensure reproducibility by fixing the random seed. As you already know that the train test split function randomly shuffles the data, right? So if you are going to rerun your code after running it once, then the same data points may not be taken in the train set or the test set. So to ensure that each time the same data points are assigned to the train and test set to maintain the reproducibility, we have to assign the random state to some value. The value can be arbitrary. Let's say instead of 0 you are passing in 42 or 123 or any number, but it should be consistent. Like if it is 0 now, then it should remain 0 in your other runs of the code as well. If you are going to change it at that time, then again randomness would be incorporated in the data while dividing it into the train and test split. After splitting the data into train and test, we can also check the shape of each of the sets, the train, the x train, y train, x test and y test. You can see here that earlier it was 25:1, but now the train set is having 18 rows and 1 column, and the test set is having 7 rows and 1 column. Okay, so in feature engineering we have learned to separate the features and the targets and to split the data into train and test. The next step is fitting the model. That is Training a linear regression model. Model training involves the process of fitting a machine learning algorithm or model to the training data. The model learns the patterns and relationships present in the training set, enabling it to make predictions or classification on new unseen data. Here in this project, we are trying to make predictions and not perform classification. Now, during model training, the algorithm analyzes the features and their corresponding target variables. That is, it is going to analyze a column, R's column, and would try to map its values to the target column, that is the scores column. By understanding the patterns and dependencies in the data, the model adjusts its internal parameters to minimize the difference between its predicted outputs and the actual values. Here, the goal is to find the best configuration of the model that optimizes its performance on the training data. In this particular project, we have a data set consisting the number of hours studied as the input feature and the corresponding scores achieved as the target. Now, based on the visual analysis that we conducted earlier, there appears to be a linear relationship between the hours studied and the scores obtained. Considering this linear relationship, it is reasonable to choose linear regression as the training model. Linear regression will help us capture and quantify the relationship between the hours studied and the scores achieved. It will also allow us to estimate the coefficients and intercept that define the best fit line, enabling us to make predictions on new and unseen data. Now let us just come to the code. Here you can see that we have created an object of the linear regression class called as model. So now that we have defined the object of the linear regression class, we will now use this object to call the fit function, and to this function we are passing the feature and target from the training set. We have already discussed that the model is trained using the training set, and that is why only X train and Y train are being passed to it so that the model can learn the relationship between two variables, that is features and target. Now, once we have fit the model, we can say that at this point our model has been trained. We can also visualize the line of best fit. Here you can see that we have set the size of the figure. Then we make use of the regplot function from the Seaborn library, and to the X parameter, that is to the X axis, we are passing the X train, that is the features from the training set, and to the Y axis we are passing Y train, that is the target from the training set. After that, we are labeling the X and Y axis by making use of the X label and Y label functions. After that, we are making use of the title function to assign a title to the plot. As you can see here in this plot, this is the title, that is regression line. Again, for this we are making use of the matplotlib library here and not the Seaborn library. Then again plt.show, as we have already discussed in the project earlier, that it is used to ensure that the figure is displayed in the notebook. So this is the graph, that is how it is coming out to be. You can see that the circle here represents the data points from the training set, that is X train and Y train, and the line of best fit passing through them is also plotted here. We can also see that some confidence interval has also been shown here. So this is how we can visualize a linear regression, and it should be noted that this function, that is regplot here, is actually using the linear regression functionality from the scikit-learn library under the hood. That is, at its back end, it is utilizing the linear regression class from scikit-learn only. So that is why we can say that to visualize this regression, we can make use of this regplot function and pass the same parameters, that is X train and Y train, to it in order to visualize it. You could have also passed X and Y instead of X train and Y train, and you could have seen the regression on the whole data. So at this point we have covered feature engineering and model training. The next step is model evaluation. Once a model has been trained, the next step is the model evaluation process, where we assess the model's performance and make predictions on unseen data. For this, we have already separated our data into train and test set. We have not used the test set so far. This test set can also be called as the validation set in this project. Using this validation set or the test set, we can evaluate the model's performance on unseen data. Let us come to the code now. In the first line of the code here, you can see that we are making use of our train model to call the predict function, to which we have passed the features from the test set. What we are trying to do here is, by making use of a train model and the features from the test set, we are trying to predict the target from the test set. We are storing these predictions in a variable called yPredict. You can see that the predicted values are in the form of a 2D array, that is the same format as that of the y test and the x test. So at this point, we have the predicted values for the test set and the original values as well. In order to calculate the model's performance, what we want to establish is that how different are the predictions from the original values, that is the test set. So we want to calculate the error between the yPredict and yTest. For this, we are going to make use of the mean absolute error function. Note that there are a lot of functions available to calculate such differences between the original and the predicted values. Here we are using mean absolute error, but you can also use a mean squared error or root mean squared error or R² value. So here to this function, we have passed the original values of the target, that is yTest, and the predicted value of the target, that is yPred. Please note that these predicted values are only corresponding to the test set and it has nothing to do with the train set. Train set was only used for the purpose of training the model, and after that, to test the model performance, we make use of the validation set or the test set. So we are calculating the mean absolute error here, and we are saving the resultant value into a variable called MAE, as you can see. Similar way, and in a similar way, using functions like mean squared error and R2 score, you can calculate the mean squared and R² metrics for model evaluation as well. The format would be the same, only the function here would change. Moreover, please note that in this project, we are training a single linear regression model to predict scores based on the number of hours studied. Since we are using only one model, the evaluation metrics may not hold as much meaning in comparison to scenarios where multiple models are trained and compared. Typically, when evaluating multiple models, we rely on evaluation metrics such as mean absolute error, root mean square, and so on to compare the performance of different models. The metrics provide valuable insights into how well the models are performing in terms of performance, accuracy, variability explained, or deviation from the actual values. However, in this particular project, since we are training only one model, the focus is more on understanding the relationship between the number of hours studied and the corresponding scores. The evaluation matrix in this case, the MAE, provides a quantitative measure of the average deviation between the predicted and the actual scores, but its interpretation may not be as critical in the absence of other models for comparison. So in this case, you can say that your predicted values may vary from your original values by a value of 4.13 or less. Now that we are done with evaluating our model, we can use it to make predictions on new and unseen data. Now that we have trained our linear regression model and evaluated its performance, we can use it to make predictions on new and unseen data points. In this section, we will demonstrate how to predict the score for a given number of hours studied using the trained model. Let us take an example where we want to predict the score for a student who has studied for 9.25 hours. To make this prediction, we need to create a new array named as xnew. The choice of name is arbitrary, you can choose any name. That will contain the input feature value of 9.2 hours. So here, in this code snippet, we are creating a NumPy array which contains the value 9.25 representing the 9.25 hours. Here we are making use of the double square brackets to represent a two-dimensional array which we are passing to the predict function in the next line. You can see that we have already learned this in the previous step of model evaluation. We are essentially doing the same thing in here but with a new unseen data. Previously we have passed in xtest, that is the feature from the test set, to make predictions on the targets from the test set. And now we are passing in a completely new data point to make the prediction. This predicted value is being stored in a new variable named as ynew. On running this code cell, the predicted value will be stored in the variable called ynew. In the result shown here, you can see that if a student studies for approximately 9.2 hours, then that student is more likely to score anywhere between 93 to 94%. Let us take another example. Here, instead of 9.25 hours, we are trying to predict the score for a student who has studied for 6.5 hours. Now, there is a slight change from the previous code here. You can see that first we are just creating a one-dimensional array using the NumPy library, and then using the reshape function from the NumPy library, we are reshaping the one-dimensional array into a two-dimensional array containing the value 6.5. Then again we are following the same procedure. We pass this new data point to the predict function and make predictions for the same. It is important to keep in mind that in the provided code snippets here, we are making the new data to be two-dimensional. We have learned two ways in which we can do the same. This is necessary because the model was trained on a data set that followed a specific shape. As we have discussed earlier in the project, the model expects the input to be in the form of a two-dimensional array. By ensuring that the new data has the same shape as the training data, we can ensure compatibility with the model's expectations. So, we cannot directly pass the numerical values to the model to make predictions. In this case, you are bound to face errors. It is necessary to convert the numerical value into a form that is acceptable by the model in order to make the predictions. So this is the end of this project. In this project, we first learned to import necessary libraries. Then the next step was to load the data. In this case, we have made use of a URL that contained a CSV file to load the data into a CSV file. And then we visualized our data. After that, we performed some feature engineering techniques such as feature and target separation and train test split, following which we were able to train our model and visualize the line of best fit as well. Once the model was trained, we learned to evaluate the model's performance by making use of the mean absolute error function, and then we saw how we can use the model to make predictions on new unseen data. So this is the general workflow of any end-to-end machine learning project. You have successfully learned to build a student marks prediction model. I hope this walkthrough has helped you to demystify the magic behind machine learning and regression. Remember, this is just the beginning. With this foundation, you can dive into more complex models in the upcoming sections. Thank you.